All right, so this is graphing absolute value of functions. It's our first section in our second mod. So what we're looking at is absolute value. This represents the distance from 0, okay? Since it is a distance, our values will always be positive. Okay, so then it's written as 2 bars, and then our x is put into there, okay? So what we have is our function f of x is equal to the absolute value of x is equal to the set such that when x is greater than 0, we're looking at that. And then we also have the negative side of it. So that's kind of our domain, and that's our domain. Sorry. Yeah, that's our domain. So if we put negative 4 in, 4. If we put negative 2 in, 2. Put 0 in, you get 0. You put 4 in, you get 4. If you put 6 in, you get 6. So if we plot it, negative 2, 2, right about there, 0, 0, 3, 4, right about there, 6. We're going to go into my table a little bit. And then we're just going to connect those points. And not too bad. So it looks something like that. Okay. So f of x is symmetric across the y-axis. Okay. So meaning that if I put this point, I can fold it across the y-axis and it'll go right on top of each other. Pretty nice. Okay. So fx is symmetric across the y-axis and is therefore an even function. Okay. The domain, we're not limited to anything on our x's. Okay. I guess I better scoot that up. I apologize. So f of x is symmetric across the y-axis and is therefore an even function. So the domain of f of x is going to be negative infinity to infinity because nothing's stopping us. Then the range is because with the lowest we have is 0. We're going to put a little bracket at 0 and we go to positive infinity. Okay. So then the next part we're looking at is we're going to be looking at the transformations of absolute value and the functions. All right. So kind of review a little bit from what we did in the first mod. All right. We have A, B, H, and K. A, B, H, and K. Remember, this can be plus or minus, this can be plus or minus, this can be plus or minus, and this can be plus or minus. Okay. So A is our vertical stretch / compression of the value A, and it's a flip around the x-axis, and we just multiply by the given A. Okay, so if it's a whole number, you multiply by a whole number. If it's a fraction, then you just multiply it by the fraction, okay? This affects the y-coordinate. Okay, B is the horizontal stretch slash compression of value B, and this is a flip around the y axis. Scoot that over so you guys can see. Okay. So this time, this is a multiply by, I'm going to say the inverse. So if it gives it to you as a whole number, remember you're multiplying by its opposite. So if it's a whole number, it's actually a compression, horizontal compression. If it's a fraction, then it's actually a horizontal stretch. Okay. So you kind of have to multiply by the inverse of your B. Okay. And this affects our x coordinate. H is a horizontal shift, so it affects the x coordinate, and we move it left or right, and we have to do the opposite of the sign. Sign. So if it's a positive, obviously we're moving to the left. If it's negative, we move to the right. Okay. K is a vertical shift, and this shifts the y coordinate. And it's going to go up or down to the direction of the y, or excuse me, of the k value. So if it's negative, you're going down. If it's positive, you go up. Okay? All right, so if we look at our examples here, the first one says the graph g of x is equal to the absolute value of x plus 4 will be the graph of f of x is equal to the absolute value of x translated up 4 units. All right. The graph of g of x is equal to absolute value of x minus 8 will be the graph of f of x is equal to absolute value of x translated down 8 units. Okay. I think we can get the rest of them in there like that. All right. The graph g of x is equal to absolute value of x will be the graph of f of x is equal to the absolute value of x translated. Let's see here. It's negative, so it's affecting the stuff inside of it. So we're going to translate it to the right 4 units. Okay. This time we have g of x is equal to absolute value of x plus 6. So it's going to be translated to the left 6 units. Okay. All right. This one's going to be a little bit different. The graph g of x is equal to negative 2. Absolute value of x will be the graph of f of x is equal to the absolute value of x. And this time we are going to stretch it. Stretch vertically by a factor of 4. And I guess I'll just finish it. We will flip it. It's outside, so where we flip it across, reflect it, not flip it, reflect it. I apologize. You gotta use your terminology. All right. The graph g of x is equal to 1/4 absolute value of x will be the graph of f of x is equal to absolute value of x compressed vertically by a factor of 1/4. Okay. All right. So what we're going to do next, we're going to do a couple actual problems with it so we can kind of see it. I'm going to try and break it up a little bit for us. We might have to stop this one and upload the next video because it's getting close to the time limit. We'll do that.